What's your name?
My name's Sherry. Adam, start
Ela me envolve. Esse olhar dela mata mais que 1000 revólver. Tá querendo guerra, eu tô procurando.
And my name's Robert.
Device that the robot uses to pick up objects. When air pressure is applied, the gripper opens, and when the air pressure is released, the gripper will close. Alright, so that is the directional control valve, which controls the direction of the airflow. Okay, that is the solenoid, which electronically controls the direction of airflow valve. That is the push button manually activated off the
Now, as explained earlier with the other robot, when pressure is added to the gripper will stay open. Then when we take away the pressure using the directional control valve by activating the solenoid, it'll take away the pressure and it'll close the gripper. This allows the gripper to grab onto something such as this ink pen, pick it up and move it around. Now, we had a few calculations that we had to do for our video. Now, we've set our pressure at 25 psi. Some of the other formulas I used was how to determine pressure, force, or area, and torque, force, or radius, and then a more in-depth version of how to find area using the diameter of the cylinder, and how to find the radius also using the diameter of the cylinder. For our first calculation, I wanted to find the area of the cylinder. To do that, I took area equals pi divided by 4 times diameter squared. Now, I made a little sketch here to try and give you an idea of how this cylinder is laid out. The cylinder is roughly about 1 inch in outer diameter. Around the wall of the cylinder, we have about 1/8 inch diameter for the wall, and then about 1/4 inch diameter for the rod inside of the cylinder. Now, by using area equals pi divided by 4 times diameter squared, take the diameter of the rod, for example, which is 1/4 inch, which that 1/4 inch ended up being 0.25 inches. So we take that 0.25 inches, times it by pi divided by 4, which ended up being 0.7854, and we ended up with the area of the rod as 0.049 inches squared. And then we follow the same steps to find the effective area of the space inside the cylinder to see how much air pressure is, or for the area that the air pressure is actually seen. The effective area ended up being 0.3927 inches squared. Using that information, we can now figure out what force is. Our pressure that we set at 25 psi is being multiplied by the area, the effective area of the cylinder. Force ended up being 9.8175 pounds. Just pounds. Don't know why inches is in there. Now that we found force, we can now find torque, which is force times radius. to find radius, in the first place, we had to take the diameter of the effective area of the cylinder and divide it by 2, which ended up being 0.5 inches divided by 2, which ended up being 0.25 inches. Now to find torque. For torque, we use force, which is 9.8175 pounds times 0.3927 inches squared. Ended up with a torque value of 3.855 inch-pounds. Now we had to convert our inch-pounds into newton meters. For every 1 inch-pound is 0.113 newton meters. So we take our 3.855 inch-pounds from our torque, times that by 0.113 newton meters to get 0.436 newton meters for our torque. Overall, torque is actually what we were looking for as our main calculation, but with a happy little surprise, you have to use multiple formulas just to find torque. Where we needed 2 calculations, we ended up with 5. Mic drop. So this has been Adam, Jarrett, and Robert explaining to you how a gripper works on a robot. Have fun.
That is the push button manually activated off the solenoid.
Now, what is the directional control valve actually controlling? Gripper! Gripper!